4.2.1, part 2. We're going to continue on with kinetic and potential energy. Energy can either be kinetic or potential energy. Kinetic energy is contained in moving objects. Objects with kinetic energy can do work. When you roll a bowling ball down the lane, you do work on the ball to cause motion. The moving ball has kinetic energy. As a result, the ball can do work on the pins. Potential energy is energy that is stored by way of an object's chemical makeup, elasticity, or position. The food you eat, a stretched rubber band, and books on a bookshelf all have potential energy. Consider the position of two books in a bookcase. They have equal mass, but one is on top of the shelf and the other is on the bottom shelf. According to the equation F equals m times A, each book would exert the same amount of force if it were to fall to the ground. However, the potential energy stored in each book is different because of the distance they would fall. Experience would suggest that the amount of work gravity exerts on the book from the top shelf would be greater than the amount of work exerted on the book from the bottom shelf. And if both books landed on your foot, you would know which one fell from the higher shelf. Even though energy is invisible and untouchable and cannot be measured directly, energy can be measured with great accuracy indirectly. It is not just a substance, but it is real. Like work, energy is measured in joules. So something with that is if you were to drop, let's say, a penny from a one-story building, it might hurt if it landed on your head, but it's not going to do a lot of damage. If you were to drop a penny from the top of the Empire State Building or the Eiffel Tower or even the Statue of Liberty, the energy that penny would pick up as it falls over that distance and as gravity pulls it down, it's going to cause that penny to go at a much faster rate, having a higher, more destructive contact by the time it hits an object. So if you were to drop a penny from the top of a high building and it were to hit someone, once it hit the ground, it could do some serious damage of injuring that person because of the energy that has built up over the distance it has fallen. But that same penny wouldn't do a lot of damage if it were dropped from a window from the first floor or dropped a foot from your hand to the pavement. And so there is a difference, even though it's the same penny, they have the same mass, the distance it has to travel does increase the force in which it collects in energy. For your information, yellow box on the left-hand side, get the ball rolling. Have you ever heard someone say, just get the ball rolling? People understand that the hardest part of doing a project is starting it. This phrase implies that it is easier to keep something in motion than it is to get it moving in the first place. Imagine the amount of energy needed to get a large boulder moving. It may take 2 or 3 people, but once it's moving, it may take only one person to keep it going. A ball has potential energy when it's just sitting, and it is also subject to static friction. As soon as enough force is added to overcome static friction, the ball has kinetic energy, and the kinetic friction is much less resistant to motion. The work involved to start the ball rolling requires a large amount of energy. Once the ball is rolling, however, the work is much easier. I'm sure that you've experienced that in some way, shape, or form. If you've rolled a snowman ball and it's really hard to get it started, but once you get it rolling, especially if you're going downhill, it's much easier to move. Or like they said, if you're moving a rock, once you get it going, it's easier to keep it going. If you have ever tried pushing a car before, if someone's broken down and they put the car in neutral and you try and help push it, the initial pushing it to get over that friction between the tires and the road is really strong. But once you get past that, it's a lot easier to push it. Once the motion is in place, moving it is a lot easier. And so the same goes with what they're saying here. with the term get the ball rolling, because once you get the ball rolling, it's a lot easier to keep going. Questions for you to answer today. You do not have a lab to do today because you do not have a Newton spring scale in order to complete the lab, but I would like you to answer the questions at the bottom of the chapter. So, number 1, what is work? 2, according to scientific definition, which of these is considered work? Picking up a pencil or holding a heavy box? Why? 3, how much work is required to push a 29 Newton object over a distance of 6 meters? Go back to the page before and look at that example in the gray box that shows you how to use the formula to answer that. 4, what is energy? And 5, explain the difference between kinetic and potential energy. If you have any questions on this as you're doing it, feel free to contact me and we can Zoom and go over the answers together. I'll see you next time.